let's just dive right into this explainer, shall we? Today, we're tackling a massive, glaring vulnerability in our rapidly evolving AI agent deployments. As AI shifts from those simple chatbots we're all used to into these autonomous agents actually operating on our behalf, the plumbing, the infrastructure connecting them has quietly become one of the most critical challenges in tech right now. So we're going to look at the fascinating intersection of two major protocols, the Model Context Protocol and the Agent Transport Protocol, and see exactly how they fit together. It's like a giant puzzle, and the pieces just snap perfectly into place. Here's our roadmap for the explainer. We'll start with MCP's missing layer, move on to the translation bridge, look at instant server superpowers, discuss moving from endpoints to citizens, and finally wrap up with the agent economy substrate. Okay, Section 1, MCP's missing layer. So first off, we have to acknowledge what the Model Context Protocol, or MCP, got absolutely right. Before MCP came along, every single tool and client had to be custom wired together. It was a mess, right? But MCP successfully united the community. It defined a clean, shared JSON-RPC protocol for tools, resources, and prompts, effectively giving AI clients a stable vocabulary to speak to servers without needing this tedious bilateral integration. Huge players like Claude Desktop and Klein use it, and honestly, it's doing exactly what a great protocol should do, creating a stable foundation so developers can just build. But, and this is absolutely crucial, MCP deliberately punted on everything underneath that tool call. Now, architecture-wise, this was actually a really sound decision. They chose to define one thing perfectly, the shape of the message. But the trade-off is that it leaves things like identity, transport security, scope enforcement, budget limits, and cross-agent attribution entirely up to the surrounding infrastructure. So MCP handles the actual tool call, sure, but it just completely assumes something else out there is handling the secure environment. And that right there brings us to the core issue. The problem is, almost no one is handling the rest. Right now, most of these MCP deployments, they're just running over standard input-output or basic HTTP. They rely on whatever ad hoc identity model or random logging the host application happens to have thrown together. And look, if you're just running local subprocesses on your own laptop, that's totally fine. But the moment you expose MCP across organizations for real high-stakes agent operations, there's absolutely no way you can rely on ad hoc plumbing. It's a massive vulnerability just waiting to be exploited. Which brings us perfectly to Section 2, the translation bridge. Enter AGTP, or the Agent Transport Protocol. Now, let's be clear, AGTP is not trying to compete with MCP, not at all. Instead, it is the exact surface layer you need when you actually design a secure agent deployment on purpose. Think of it as a substrate. It's this foundational layer carrying all the vital governance and security data, which frees up application protocols like MCP to just focus on what they do best, delivering their specific messages. A really good way to picture this is a telephone call. In this analogy, MCP is the JSON-RPC language the agents are speaking to each other. But AGTP is the secure telephone line itself. It gives you the caller ID, the encrypted wire, the call recording, and even the billing limitations, all baked right in. I mean, you wouldn't conduct highly sensitive business over an unencrypted radio frequency where literally anyone could tune in, right? You want a secure line, and that is exactly what AGTP gives to MCP. The way these two connect is just incredibly elegant. The AGTP-MCP Gateway relies on a single Python process that does exactly four things. First, it terminates the secure TLS connection. Second, it verifies the identity of the calling agent. Third, it enforces strict policies like budgets and scopes. And fourth, it translates those verbs into JSON-RPC and just passes them along. And because it passes this data over standard input-output to unmodified backend servers, your official file system or Brave Search MCP implementations don't even know AGTP is there. It's completely seamless. Let's move into Section 3, Instant Server Superpowers. Because the gateway handles all that heavy lifting and security up front, your existing MCP server's source code doesn't change at all. Zero changes. You just run the gateway in front of it. This is honestly a real game changer for both ecosystems. The MCP community can keep intensely focused on evolving their tool protocol, and the AGTP community can keep evolving their transport protocol, completely independently of one another. Both get much stronger, and absolutely nobody has to compromise. To put that into perspective, the transformation is literally night and day. Without the gateway, we're in this risky environment, relying on whatever authorization the operator haphazardly wired up over basic HTTP. But with it, we move to a hardened environment, utilizing mutual TLS by default. We go from hidden, ghost-like identities to fully verified cryptographic IDs. The backing MCP server is still just happily speaking its normal language to its child process, but all that complex transport security is completely handled at the AGTP layer long before the request even reaches it. So, what exactly are these superpowers your server instantly gains? Well, there are four major ones. First, cryptographic agent identity. The gateway verifies a signed identity document against a registry, so you know exactly, with absolute certainty, who is calling. Second, authority scope enforcement. It automatically rejects requests if the agent lacks the specific scope tokens needed for sensitive tools. Third, budget limit bounds. This is huge because it stops agents from spiraling into massively expensive loop calls by tracking consumption right at the wire. And fourth, signed attribution records. It writes these append-only, cryptographically signed logs using an ED25549 key for every single consequential interaction. Now, you might be wondering, is this a nightmare to set up? Actually, no. It's remarkably simple. If you're an MCP operator, you just point the gateway at your existing server. You configure your TLS certificates, point to your AGTP registry and signing keys, and then just set a single environment variable, AGTP_MCP backend, to launch your server. That is literally the whole shebang. And the coolest part? Legacy clients can still connect using your old setup right alongside the new AGTP-aware ones. It's totally painless and incremental. All right, moving to Section 4, from endpoints to citizens. When an MCP server runs behind the AGTP gateway, a small syntactic detail creates a massive ripple effect. It acquires an AGTP URI. Basically, the host domain becomes a namespace, kind of like how gmail.com is a namespace for your email. So if we have an agent hosted there, let's call our Lauren, for example, she actually gets her own canonical address, agtp/mcp.example.tld/Lauren. This shift is profound. Instead of being this faceless, vendor-specific HTTP URL pointing to some random JSON-RPC endpoint, Lauren becomes a named, fully accountable citizen. Under AGTP, she becomes a discoverable entity within the Agent Name Service, or ANS. This means other agents can actually search for her capabilities, and she can even earn behavioral trust scores over time. We are literally moving from a world of hidden endpoints to a true functioning society of digital citizens. And here is the truly brilliant part about her security. Lauren's canonical agent ID is actually a cryptographic hash of her genesis. She isn't just a convenient label slapped onto a hostname. Because our core identity is cryptographically tied to her creation, she stays Lauren even if her server is completely migrated to a different host. This means Lauren the agent can be safely delegated to and held fully accountable. It provides the absolute, rock-solid trust you need to build a functional AI economy. Finally, let's wrap things up in Section 5, the agent economy substrate. When we step back, the success of this whole MCP bridge is the ultimate existence proof for what we call the substrate thesis. It proves that AGTP acts as a universal substrate, a secure transport layer that solves discovery, identity, and scope once and for all. And because AGTP handles that heavy lifting, application protocols like MCP, A2A, or ACP can just stick to their specific domain messages and tasks. The boundary is incredibly clean, the composition just works perfectly, and it hits the nail on the head for the exact security problem the agent space has been wrestling with. Looking to the future, the possibilities are just wide open. As the AGTP ecosystem matures, these unmodified MCP servers are going to seamlessly compose with agent name service discovery, federated registries, and immutable transparency logs. We'll start seeing completely secure cross-organization delegation and the emergence of true marketplace primitives, where agents can securely buy and sell services with each other. It takes everyone's existing architecture and makes it infinitely stronger without forcing anyone to scrap their core tools. So I want to leave you with this provocative thought as we wrap up this explainer. We know that protocols only truly succeed by doing one thing perfectly, right? Well, as these open standards merge cleanly at the gateway, with MCP brilliantly handling the tools and AGTP securely handling the trust, what previously impossible, high-stakes tasks will you finally trust your AI citizens to tackle now that they actually have a secure foundation underneath them? Thanks so much for exploring this with me today.